What's the relationship between making perfume and pesticides? Or between the production of modern medicine and Paris Fashion Week? At first glance, they don't share much of anything. But look a little deeper, and you'll realize that each of these different subjects relies on organic compounds. And without organic chemistry, we couldn't have any of it. The fundamentals of organic chemistry drives innovation and progress in every field you can imagine, from biotechnology to plastics and perfume. Let me show you what I mean. This is ASU. Organic chemistry has a terrible reputation of being a difficult subject matter to understand, and most people recognize it as a dense, weed-out course for college students majoring in sciences or for those who want to go to medical school. But what is organic chemistry, and why is it important and relevant for us to study it? Organic chemistry is a subfield of chemistry focusing on the properties and reactions of molecules that contain carbon atoms. And you actually know a lot about organic chemistry already because you yourself are a living organism that is made up of many different types of carbon-based molecules. For example, your DNA that holds unique genetic information that makes up you contains carbon atoms. If you pull your hair or touch your skin, you're actually touching fibrous proteins called keratin that are also made up of carbon atoms. Carbon-based biomolecules are not specific to the human body and other living organisms. They also largely make up the food that we consume for energy. When we eat a chocolate chip cookie, we're consuming carbohydrates, more specifically sugars and starches, which all contain carbon atoms. Proteins and fats that we eat are carbon-based, and these molecules help us to produce muscle and hormones for our bodies. But wait, there is more. Studying organic chemistry and carbon-based molecules also helps us to better understand the world around us because they are literally found in all facets of our daily lives. Because we are carbon-based life forms, the medicines used to treat our illnesses and diseases are carbon-based as well. This is why learning organic chemistry is such an integral part of drug discovery and development, as well as important for making advancements in healthcare and medicine. Sometimes when I have a rough day at work, I wonder what I would do without the help of ibuprofen. And when I have a bad allergic reaction, antihistamine drugs come to my rescue. Organic chemistry is also used to develop and formulate products that we use in our homes, from soaps that we use to wash our hands to the polymers that are found in plastics and in nylon that probably make up some portion of the fabric that you're wearing right now. Gasoline that we use to fuel our vehicles is largely made up of hydrocarbons, and as much as we should be thinking about the impact on the environment, we cannot deny how it has allowed us to travel from one place to another, essentially around the globe with ease. So let's go back to why do we study organic chemistry and why is it relevant? Whether we like it or not, organic, carbon-based molecules are essentially found everywhere and are a large part of who we are as living organisms. A better understanding of organic chemistry is essential for us to not only better understand ourselves, but to make progress as a society. Organic chemistry is much more than just a class you take in college. It teaches us about who we are and where we should be going. So everywhere we look, organic chemistry has had a profound effect on our very existence as human beings. From the food we eat to the clothes we wear, every facet of our lives depends on it. And scientific advancements we can't even imagine now will depend on the development of new organic compounds in the future. It's amazing that something so small and commonplace can have such a meaningful, foundational place in our world. This was ASU. Thanks for watching.